Well, let's assume that we have done the study properly. Now the question is, what do we do with the findings from the study? And so to recapitulate before turning to how we analyze these data, remember that in a cohort study, we're comparing exposed people to non-exposed. And in a case control study, we're comparing cases, people with the disease, to controls, people without the disease. And we're then looking at the rates of disease in exposed people in a cohort study, and we're looking at the proportion exposed of the cases and the controls in a case control study. Both of these approaches are aimed at demonstrating whether or not there's an association of exposure and the development of disease. Let's go back to our original question. We're carrying out these studies in order to determine whether there's an association between an exposure and a disease or adverse health outcome. Or, as it's restated here, is there an excess risk of disease in people who have been exposed? I'd therefore like to turn to the question of how we measure excess risk. The first measure of excess risk is the relative risk. Relative risk is perhaps the most commonly used measure of increased risk. What does it mean? The relative risk is the ratio of the risk of disease in exposed people divided by the risk of disease in the non-exposed people. How do we interpret that? Well, if the relative risk equals 1, it means the numerator of that fraction. The numerator is the same as the denominator. The risk in exposed people is the same as the risk in unexposed people, and there is no association between exposure and disease. If the relative risk is greater than 1, it means that the numerator is greater than the denominator. The risk of disease in exposed people is greater than the risk in non-exposed people, and this is a positive association, and it may be causal. And we will shortly discuss how we move from association to causation. If the relative risk is less than 1, the risk in exposed people is less than the risk in unexposed. The numerator is smaller than the denominator. This is a negative association and could be protective. For example, if we have an effective vaccine, we would expect to see a relative risk less than 1 because people who have been exposed to the vaccine would subsequently develop less disease than would people who had not been vaccinated. Another measure of excess risk is the odds ratio. And this is again discussed in some detail in the reference manual. Suffice to say that for general purposes, you can interpret the odds ratio just the way you would interpret a relative risk. The odds ratio is most commonly used in a case control study. The third and final measure of association that I would like to discuss with you is called the attributable risk. And the attributable risk is shown schematically in the next few slides. Let us consider an exposed group and a non-exposed group, each of which has a risk of developing disease. This bar represents the total risk of developing the disease in the exposed group, and this is the total risk of developing in the non-exposed group. For example, let us say that the exposure is radiation, and the risk is developing a certain type of cancer after radiation. What do we see? We see that the risk in the exposed group, in the radiated group, is greater than the risk in the non-exposed group, but we also see that even in the non-exposed group that was not radiated, there is some risk of developing the cancer. That is, that all the cancer is not due to the exposure because even some of the non-exposed people develop the disease. What we see is that the non-exposed group basically represent a background group. They weren't radiated in this example. They have a background risk. And this background risk is a risk that even the exposed people share because they're members of society and members of the community. If we want to ask the question, in the exposed group, how much of their exposure can we attribute to the fact that they were exposed? Or to say it differently, in the radiated group, how much of their risk of cancer is due to their having been radiated we can figure out quite clearly how to calculate this. The total risk in the exposed group is due to the exposure and to the background risk, not due to the exposure. The exposed people have an additional risk that the non-exposed people don't have. If we want to calculate how much of this risk is due to the exposure, we would take the total exposure, the total risk in the exposed group, and subtract from it the risk in the non-exposed group. This would be the attributable risk. This would tell us how much of the risk can we attribute to the exposure. The attributable risk has taken on meaning in the courts because it has been suggested that an attributable risk greater than 50% could be equated with more likely than not that a specific exposure caused the disease. This is extremely controversial and complex and is discussed in more detail in the chapter in the reference manual.